We'll practice again on Monday when we're all virtual, but you got your packet, so you'll be all ready. And then Tuesday, I think we have class, and we'll have an actual BFF quiz, okay? So here, yep. Because we'll practice today, we'll practice a couple on Monday, and then you ought to be ready. That gives you several days to get your things memorized. All right, so let's go through this first one, the one that just says Precal C Super Practice BFF Quiz. Sketch the indicated curves. So when you get an actual quiz, you're going to have to do this. There will be 3 that you will have to sketch, but it will be just random 3. All right, so what does y equals e to the x look like? See if you can do it without your cards, but certainly if you can't, get your cards out and look at them. E to the x. What does that look like? Yeah, that has an asymptote here, the 0.01, and this. That's your exponential. That is your exponential. You do. That's what it should look like right there. Okay? And the reason that point's so important is we're going to start moving this curve around, and that's going to be our reference point when we move it. Okay? Next. Oh, this is an easy one. Anybody remember what this one looks like? That's your absolute value. Value. V. Value is a V. That's right. Absolute value is a V. You do not have to label the origin, but that's where it comes out of. Remember, absolute value V. All right, and then how about this one? This is the square root function. What does that one look like, Caroline? And then shooting out, right. Don't make it a straight line. Make sure you're arcing it out. That's your absolute value. All right. Yes, Katie?
Make that like dot at the origin?
Yes. That's your starting point. All right. So next, so we got 3 that are graph. Okay. Now we have 3 that are write the name. So let's do that. So this is number 2, right? A. What picture is that? The one that has the 2 asymptotes, Gabe?
Logistic.
That's logistic. And remember, you cannot abbreviate that one, kids. You can abbreviate some of the others, that's fine. You cannot abbreviate that one. That one you're going to write logistic. Okay? And then B, what's that one? Greatest integer. Yeah. So remember, we're writing the name of the function. Okay? And what about C? Squaring or quadratic. Whichever word you use, they're both fine. So you can say squaring or you can say quadratic. That is exactly right. Parabola, that's your squaring function. So we've done 3 of them by picture. Now we've done 3 of them by name. So the next 3, we're doing by equation. So what about A? That's the identity. I need the equation of it though, so I'll write identity because that's what it is. But the equation is y equals x. That's exactly right. That's exactly right. Y equals x. This one says write the equation. So follow the directions. So we're on part 3 and we're writing the equation. Gabe?
I was going to do B.
Okay, what's B? What's the equation for B?
Log x.
Yep, y equals log x. If you wrote y equals ln x, that would be fine. Either one of those is fine. They're both perfectly acceptable. That's your logarithmic function. C is a trick one. Pay real close attention.
Cosine?
Yes, it's the cosine. Why is it not the sine? Doesn't go through the origin, the middle, yeah. So this is a cosine, and the abbreviation is COSX, the equation COS, cosine. Okay? Now here is often the trickiest part. For the last the last three, we've done 9 so far. For the last 3, you just have to remember which ones you haven't used. Okay? So can you think of the 3 that have not already been covered somewhere on the quiz? Gabe?
Y equals sine x.
Sine x, absolutely. Now, notice that you can write the equation, you can write the name, or you can draw the picture. Whatever flips your switch, okay? You only have to do one of those things, but it says draw, name, or write the equation. So I drew, I named, I wrote the equation. One or the other. Any of those will work fine. Caroline?
The cubing function?
Cubing function is missing. So you can write cubing, you can write y equals x cubed, or you can draw the picture. Beautiful. Cubing function is missing. Trey?
Reciprocal.
The reciprocal function is missing. So you can write the word, you can even abbreviate that one if you want. You can write the equation, or you can draw the picture. You can mix and match those. So on that last part, however you write it is fine. Name, equation, picture for each one of those. Okay? Let's turn it over and let's just do the back side, and then we really do have to move on. Now we're on BFF practice number 2. And notice that it's formatted exactly the same way, right? Which is exactly how your quiz is going to look. So the first thing we are doing is sketching the curves. What's that first one? What kind of crazy equation is that? That's the logistic curve. This is logistic. And remember, the logistic one is the one that has the 2 asymptotes. And then that. So your job is to sketch the curve. There it is. Okay. What about B? Okay, just in the air, show me what a cosine looks like. Up and down, right? So is this the one, it's cosine. Do I start here and start my up and down, or do I start up here and do my up and down? Up there, right. So up and down, up and down.
We're gonna have a quiz over this before, like what you have to do about it, before we start to learn how to insert stuff in, right? We're gonna have like a.
The quiz on Tuesday
It's just
is gonna
over-
look exactly like this.
Okay, and then after that, are we gonna learn like how to, like, are we gonna put it with problems and equations?
Yes, well, we're gonna actually start that today, but that will not be on your quiz.
Oh, okay, thank you.
That will not be on your quiz. Your quiz is just memorization.
Okay.
Cosine and sine, do we need to like do that like perfectly, or it's like?
Well, it needs to be pretty good.
Okay.
I mean, I don't want to have, one hill be way up high and everything. It doesn't have to be exact, but it has to be close. Katie?
Do we need arrows on this one?
Pardon me?
Do we need arrows on the end of this one?
Yes. There should be arrows on the ends of all of them, Katie.
Yeah, I wasn't sure if I was seeing.
Yeah, they all have arrows on the ends of them. The only, like the, square root function does not have an arrow on this end, but it has an arrow on that end. Okay, what's C? That's your reciprocal function, so that's the one. It also has two asymptotes, but it's got a piece up here and a piece down here. Right? Okay, so now we're going to write the name of the function. So I've given you the picture. What's that? Identity. And remember, you're writing the name. We're following the directions. So it's identity.
I wrote linear, that's fine.
Linear is fine. Yep. Either one of those is fine. Yes, B is the square root.
What is one of X boot?
We'll probably get to it here in a minute. This is definitely, B is definitely the square root function. What's the name of C? Greatest integer, yeah. So those are the names for number 2, problem number 2, A, B, and C. Those are the names of the function. And for the first one, you can use either one of these two names. They're both correct. You don't need both of them, either one. Okay? 3. Now we're doing the same thing, but we're writing the equation. Okay? So what do you think is the equation for that first one? Y equals log x. Or y equals ln x, either one. What's B? It's absolute value. It's absolute value, so y equals absolute value.
Is squaring the one that's kind of like that except it's a U?
Yep. So y equals absolute value, got it? All right, what's C? That's squiggly.
Y equals X to the third.
That's your cubing function, y equals x cubed. Now, here comes the tricky part. There's 3 that are missing, right? Oh, we got a pass today. Thank you. So what 3 are missing? Sign's missing. We haven't done sign. So remember, it says you can draw it, name it, or write the equation. So there's the equation, there's the name, there's the picture. Guys, listen to me. We don't have to do all 3. It's one or the other, whatever you're most comfortable with. I think we did the logarithm. I think that was 3a.
Exponential.
Exponential, let me double check. We did not do exponential. So B would be exponential. And that equation is y equals e to the x. And that picture, if you draw it, is that. One more missing, Caroline. The squaring function, we haven't used that one. So y equals x squared, squaring, or quadratic, or the picture. Okay? Now, those of you who want to practice some more on your own, there's more here. We're going to do these on Monday. I need you to have paper copies on Monday. So please don't mark these up. You can print them from Schoology or do them in Notability from Schoology, but keep these blank so that you can work along with us on Monday. Got it? Because I know some of you will study, and that's absolutely wonderful, but I want you to do it on the extra copies in Schoology, not on this packet. All right, so that's good. All right, so now we've got almost everyone here. It isn't every day that you have a sectional champion in your midst, and we do. Katie, sectional champion. Yeah, Katie. So we are going to celebrate with a treat. So I need you to take a napkin and then take a brownie. Take one napkin and then take a brownie. Got it. Okay. You want one of these?
What if we want to stay?
Well, then you'll be eating food treats.
Way to go.
But let's not get.
Thank you.
We gotta let us know before that happens.
It's okay, James, it's on your phone. You always make fun of me. Yesterday.
Yeah, our games are complicated.
I just never heard of this before, so like, I think 4 hours.
We want to play about this.
It's great.
Okay, did everybody get one who wants one? All right, so now we're going back to our notes, and we're gonna pick up where we left off. You will remember that we were doing a little bit of review work. So we were in our notes on page 9A. It's labeled 9A, page 9A, in our notes. It's where we left off yesterday. So we're gonna do a little practice with horizontal and vertical asymptotes and holes. Okay? So even though this is review, let's go through this carefully. This is important stuff. It's a big piece of what's going on in this chapter. So we're in our notes, guys. We're on page 9A, and we're doing number 2A. So the question is, we want horizontal asymptotes, vertical asymptotes, and holes. Now, I'm going to jump right in and say right from the get-go, this problem has no holes. How do I know that it has no holes? Nothing's going to cancel, Jameson. Perfect. The only way that holes happen is if you factor your problem and you have matching parentheses and they cancel out. We do not, well, can we factor anything here? So there's no way you're going to cancel because you have to factor before you cancel. So it's not happening. There aren't any holes. Is there a vertical asymptote? Yes. Where does it come from? Do my beady little eyes look up here or do they look down here for the vertical denominator? So my vertical asymptote is x equals what? -5. Beautiful. Beautiful. That's my vertical asymptote. Now, where do I look for my horizontal asymptote? I box it in. Your horizontal asymptote is when you box it in. So I've got a 2x over a 1x, right? So where's my horizontal asymptote? Y equals 2. Now the next problem's a little bit bigger than that.
You want us to graph those?
Nope.
Okay.
You do not have to. You certainly can if you want, but on this exercise, we are just writing them down. So same thing. I want horizontal, vertical, and holes. Now, what do I do first on this one? I can't just answer this one. This one has to be factored, right? Eli, if somebody walks by the room and your mask is down, I get in trouble. Okay. Okay. So, let's factor it. Jameson, bottom. X plus 1, x minus 1. That's called the difference of squares. We have those in almost every problem, it seems like, guys. So it's x plus, x minus. Now the top is not the difference of squares. How is it going to factor?
-5.
-5 and +1. Because -5 times 1 is -5. Yes. Out of the. Okay. Now, what do you notice about this?
Oh, that you can go on.
You have identical parentheses. When that happens, it means that you are going to have a hole, right? I'm going to have one. Because holes happen when you cancel. Holes are points, but they're open. They're not closed dots, they're open dots, but they're points. So they have an X and a Y. Now notice that what canceled, this is what's left, what canceled was this factor, which means the X coordinate of my hole is -1. Perfect. Because the thing that canceled is x plus 1. Okay. Now, this is the part we haven't spent a lot of time with. The hole is a point, like I said. So it has 2 coordinates. How do you think we're going to find the y part of that? We're just going to plug in -1. It says x is -1, right? So we're just going to put -1 in here, so we get -1 minus 5 and -1 minus 1. So whatever my x is, I just plug it in. This is my new problem right here. I just plug it in. So I get -6 over -2, which would reduce to 3. So my hole is at -1,3. Now I want you to look right here now. This is where you look. Don't look back up there anymore. Look right here. Where do I find my vertical asymptote? The denominator, right? So where's my vertical asymptote going to be? X equals 1. My horizontal, I'm going to box this in right here. That's 1 over 1, so my horizontal is at y equals 1. You could have some kids do that one first. You can do that right from the very beginning of the problem. Would you still get 1 if you did it then? Yeah. So if you want to do the horizontal first, you can. You can't get these until you factor, but you can do the horizontal right off the bat. All right, let's try the next one.
On the test, you didn't like do anything to graph that.
We are not ready to graph these curves yet. Eventually we will, Jameson, but not right now. Right now, our focus is just on identifying these. Because when we get around to graphing, that's all gonna be part of the picture. But there's other stuff that has to be part of the picture too. We haven't gotten to that yet. So right now, you'll just be making a list. All right. So take a look at the problem. Does anything factor? The bottom does. So I can go ahead and factor the bottom. So x plus 1, well, how does that factor?
X minus 2 plus.
Yep, that's the difference of squares again. But what? Nothing cancels, which simply means none. Caroline?
I was just gonna say, it cannot cancel.
Yep, if nothing cancels, you still want to factor, it's fine. But nothing cancels, so there aren't going to be any holes. There's two things in the denominator, though. So what does that mean in terms of vertical asymptotes? There's two of them. So x equals 2 and x equals negative 2. Now, why do we have two of them? Because there's two things that didn't cancel out. Now, let's go back to the original problem. I'd love to box that in, but I can't because the powers don't match. Whatever you box has to be the same. X squared, x, x cubed. So I need an x squared on the top to box in with the one on the bottom. I don't have an x squared on the top, so I'll just say 0 x squared. So now I have 0 over 1, which is 0. That'll happen every time the bottom's bigger than the top. Every time. Now the next one is exactly the same problem, but upside down. So it'll be x squared minus 4 over x plus 1. So I can go ahead and factor, but it's not going to do me any good, right? Because nothing's going to cancel. So that means no holes. Remember, there's one way to get a hole. There's only one way, and that is to cancel. If you don't cancel, you don't have one, ever. Now, I only have one thing in the denominator, so my vertical asymptote will be x equals negative 1. Very good. And I'd love to box this in, but I'm going to have to put a 0 on the bottom in order to do that. So I'm going to have 1 over 0 this time, right? What about 1 over 0?
Undefined.
Undefined. So there are no horizontal asymptotes. And that will happen every time the bottom, or excuse me, the top is bigger than the bottom. I remember, I used to be right across the hall from Mrs. Hollis. She yells loud. So I hear her all the time. And she says, you can't sit on the egg. You can't sit on the egg. That's not possible, right? 1 over 0. Doesn't work. Doesn't work. Okay? All right, that takes care of that. We aren't ready to do the back side of that yet, so hang on to that. We're going to go on to page 10 of our notes. And this is what Ella was asking me about earlier. Ella says, oh, I love all my BFFs, Mrs. Ford, but what am I going to do with them? So this is what we're going to do with them. So we're on page 10 of our notes. Page that says 10. And you are now going to graph y equals, you remember we talked about f of x is the same as y. So if you want to write f of x, that's great. If you want to write y, that's fine too. We're going to graph this. So you get out your note cards, because this shape is going to be the same as the square root. This is a square root problem. So the shape of the graph is going to be the square root. Now, I'm going to just put that over here to the side because I don't have note cards. But that's what's on my note card, right? So what I graph here is going to look exactly the same, except that -5 has moved it. Does anybody want to take a wild guess? You got 4 options, left, right, up, down. Anybody want to take a wild guess which way this thing has moved Gabe? Up, good guess, but not right.
Down.
To the right.
To the right. This one goes to the right. So this one is going 1, 2, 3, 4, 5 to the right. So you have the shape. You have the shape of the square root, but now your point is not the origin, it's the 0.5, 0. You must label that point. You're telling me where this curve has been moved to. You all right?
These are on.
Oh, Lord. Thank you for cleaning that up. Okay? Now, I want to give you the rules before we go on. You guys talked about these last year, but it's kind of hard to keep it all straight. So this one went right. Any guess where this one would go? That would go left. Write this over to the side to help you keep track. So here are the 4 movements. When the 5 is kind of inside the problem, like it's under the radical sign, or it's in the parentheses, or it's in the problem, that's left and right. Minus goes right, plus goes left. When the number is outside the problem, see the difference there? See where that 5 is? That's different. When it's outside the problem, that is up if it's plus and down if it's minus. So you might just want to write that down as an example somewhere to help you remember how to move these things. Yes?
Did you ever do like it's like x plus 5 and then there's another plus?
Yes, indeed. Yes, indeed. So Jaden says, can we like do more than one thing? Absolutely we can. We can do lots of things. We can stick negatives in front of the problem. We can put multipliers on the problem. There's all kinds of changes we're going to do. But one at a time. All right, one at a time. All right, so let's look at B. All right, use this as kind of a guide. We've got the absolute value of x and then a plus 1. It's outside. Now, keep in mind, kids, this could have been written like this. That's a different problem. This one's inside, this one's outside. And when it's outside, it's an up and down movement. So what is this going to do? It's going to go up 1. So your normal absolute value starts at the origin. This one's going to start up 1. So you're going to have your V, and it's coming from the point 0, 1. So the shape is what you've memorized or are in the process of memorizing. And now you know that the location can change. All right, so what's the next one? C. E to the x plus 1. So the next one is, now pay attention to where that plus 1 is. It could have been e to the x plus 1 like that. It's not. This plus 1 is at the end. So what's happening to that picture? Up 1. Now, keep in mind that the original, and I don't even mind if you graph the original, just do it in a different color or lightly or something. But here's the original. I'll do the original black. Here's the original, okay? Now, here's the new one. I'm gonna take that exact picture, but I'm gonna move everything up one. So this is on the axis, so that asymptote is coming up here to one now. That asymptote got moved up too. A whole thing gets moved up. And that's not the 0.01, it's now the 0.02. So there it is. There's the answer to the question. Not to this one. That's the answer to that question right there.
Okay, so it was at 0, 1, but since it said add 1, just go up.
Yep. The one on the outside is an up. That means every single part of the problem goes up 1. Okay, now look at D. D's a little bit different. What shape is it, first of all? It's a squaring. Squaring functions have what shape?
U.
Parabolas, U's. So this is going to be a U. The normal U is here. I mean, that's what your normal parabola would look like. What have we done to this? Now notice where that 1 is. It's in the parentheses, right? No. Inside is a left and right. So it's plus 1, so it will go left. So you're going to take your parabola and you're going to move it over 1 unit to the left. So now instead of sitting on the origin, it's sitting on the point -1, 0. All right, there's one more in that section. And it is y equals x squared minus 1. Now, is the shape, there's Kleenex over there by Jesus if you want them. The shape is going to be exactly the same as this shape, right? Isn't that a squaring problem? Okay, anything that's squared is going to have that shape. Now, how has this one relocated? Down 1. It's going down 1. So now you have exactly the same shape, but you have moved it down 1. All right, has everybody written this down somewhere? That would be a good guide for you till you get these memorized. That will be good. Claire?
Wait, so it doesn't matter, like, even if it's outside, it won't go down, it would just move down.
Exactly. So it won't tip upside down. It won't tip upside down. If you want to tip things upside down, you have to put a negative out in front of the problem. Okay, now we haven't done that yet, but that's how we call it a reflection across the x-axis, but that's how you tip it upside down, okay? When you add and subtract numbers, that simply picks your picture up and puts it down somewhere else, okay? Either up, down, left, or right. Okay, it does not change the shape of it at all. Okay? All right. So now the next section looks a little bit scary. I'm going to leave those up there because they might come in handy. These next functions are called piecewise. And they're called piecewise because we graph them in pieces. Okay? We're not going to panic. This is going to be a little bit different. You may have never done this before. Don't panic, it's not that hard. Let me look at the first problem.
We're on the same page as before, right?
Yeah, we're moving on, number 4. Alright, so this is the problem. You see how even the problem is written in pieces? This piece and this piece? Now, I want you to forget that it's in pieces. I want you to forget that there's anything there except this right here. So I want you just to look at this right here. Pretend that's all that's there. What does that look like? It's an absolute value, so it's what shape? It's a V. So I'm going to go ahead and I'm going to draw my V. Now, that's not hard. We know that's what it looks like. That's it. Okay? Now, I want you to look at this part of the problem right here. Doesn't matter, either one of those. They're always going to match. Those numbers are going to match. Okay? On my picture here, this is where x is 3. Would you agree with that? That's where x equals 3, right here. I want you to draw a vertical line. I'm going to dash it because it's really not part of my picture. But you can make it solid. I really don't care because we're going to erase it. Jameson? Woo! Good stuff here. Now, see where that line you just drew intersects your V? Now, that is either going to be an open dot or a closed dot right there. So I need to look back over at my problem. This was the absolute value. Look at that right there. That's going to be an open dot. So right there where it crosses, you're going to make an open dot. Is that okay? All right. Now, this says x has to be less than 3. No, we're not shading. It's a good question, though. Here's where x is 3, right? It's less than on that side and greater than on this side. So we want the part of the blue curve that is less than 3. So don't we want this part right here? So we're going to erase this part. Erase that part of the V. We do not want that part of the V. Carol? Pardon me? Oh, yeah, thank you. I wrote something wrong. Oh, this is greater than. Oh, shoot, folks. Sorry about that. Thank you, Farrell. Put this back in because that's a greater than on the problem. I wrote it wrong. That's a greater than. So I don't want this side of the V. I actually want that side of the V. So I'm going to erase all of this. Thank you so much, Farrell. That would have been a disaster later on. Thank you. So the problem tells me, when you copy it correctly, which side of the picture you keep. This says keep the side of the absolute value that's greater than 3. So that would be the right. This is the right. This is going to be the left. All right. So now I am going to graph. Let's see if I have another color. I'm going to graph the second part of my equation. So I'm going to graph this right here now, which is what shape? What? A U. Well, let's say parabola, but yeah, it's a U. So I'm going to graph that. There's my parabola. notice that it crosses my red line too, right here, right? Will that dot be open or closed? I'm doing the parabola now, so I'm looking down here. That's going to be a closed dot. And this less than tells me that I keep. This tells me what I keep. I keep the left side, so I'm going to erase the right side. And so my picture is in two pieces. It is this piece right here, which is what I kept from the V, and it is that right there, which is what I kept from the parabola. Ella?
Why is the dot all the way up that high? The purple dot.
Well, if I actually plotted that point, if I put in 3, I would get 9. So the purple dot is actually up at 9.
Okay.
If I put 3 in here, this dot is only at 3. So technically, I don't even have it high enough, but I'm not grading that, but it's above. Once in a while, Ella, they'll hook up, you know, that dot will end up here, but that usually doesn't happen.
Wait, so you're not like, you just draw however, you're not actually grading how high or how low it is?
Right. I'm not grading how high or how low it is, no. Yeah. Notice I didn't even have a scale on there until she asked the question. I just put it on there somewhere. All right, let's do one more and then I'll stop. We've done a lot today, so let's do one more. All right, B. Oh, it's a doozy. Need some room here. Here we go. You cannot possibly be bored. This is so cool. We are graphing piecewise functions. All right, so let me see if I can copy it right this time. It's a 3-parter. So x plus 1, 3, and x squared. All right. So first things first. Let's just graph this right here. The first function. Now, remember, what is that? That's a BFF. That's your identity. Your linear function goes through the origin. You are lifting it up 1. Yeah, I left the wrong one up there. And that's going to be other ones to get that out of there. We're lifting it up 1. So that's going to be up here. I'm going to draw it as nicely as I can, Katie. I'm not being totally careless, so I'm going to draw it as carefully as I can. Now that is the whole line. I just drew the whole line. But the problem tells me that I don't want the whole line. Here's where x is 0, so I'm going to dash that in. That's where x is 0. And it crosses, the purple one crosses that right here. Should that be an open dot or a closed dot? Open. That's going to be an open dot. And then this tells me which part to keep. So I want to keep the part to the left, which means I will have to erase the part to the right. So the first piece of my picture is that. Now, this part says y equals 3. Oh my gosh, that is not a BFF. What in the world does y equals 3 look like? Exactly. Everybody back there in the back row is going like this. So I'm going to come up here. I'm going to draw that line in. And that's the line where y equals 3. Now, it has to, look here, that says x is 2. So now I got another dashed line over here where x is 2. This tells me where to draw my cutoff line. Notice that my black line crosses that 2 line right here. Will that be an open dot or a closed dot? Open. And then this tells me what to keep. So this is telling me to keep the part this way, which means I will erase all of it that way. So now I have the second piece of my graph. Which is the line y equals 3, but only the part bigger than 2. All right, let's graph this. What's that shape? That's a parabola. Vertex at the origin, right? So I'm going to go ahead and draw that in. There's my parabola. Notice it crosses both lines. So I'm going to have a dot here and a dot here. Should those dots be open or closed? They're closed. So the blue dots are both closed. And then this tells me what to keep. What am I keeping this time?
Everything except for what's above the top dot.
I am keeping the part that is between 0 and 2. So that means it's between the lines. So I'm getting rid of all of this. And I'm getting rid of this little piece here. And I have just the piece between the lines. These are involved problems. There's a lot going on. So we'll practice. We'll pick up here next time and practice another one. What I want to say though, please listen, when you get done with the picture, you will always have dots lined up. Your dots should be lined up with each other. And one will be open and one will be closed. You should never have dots like off kilter, and you should never have two closed or two open on top of each other. Okay? So they're always lined up, and you always have one of each. Yes? Yes, you have to sign out. What? Can you do what? Yes, hurry up and sign out. All right.
Just have me out too.
Okay. All right. So let's come around and spray the desks. And he never showed up.
Thank you for joining this morning.
Well, thank Katie. She's the one that did all the work. But you're welcome. We're looking forward to more. All right, so everybody got a desk cleaned off? Here we go. time you're awake now, the class is over. Oh, you already have one. Let's not wipe them off until 4. We have to let it set for whatever, as long as we can. All right, I don't see you guys again until Tuesday. Makes me sad, you're welcome. I'm sure you're sad too. We'll practice for our BFF and then take our quiz. Oh shoot, I never turned that off, did I?